Section 2.5, we're going to find out how to sketch y equals modulus of f of x and y equals f of modulus of x. I've actually shown you how to do the modulus of f of x. Let's just go through this again. So, if you have a function f of x, let's have a look. I think I've done the example of a cubic before. What effectively happens when you sketch y modulus of f of x, you are going to use the graph of f of x. Any parts that are above the x-axis, they will remain as part of your answer, and what parts that were negative will be reflected in the x-axis. So altogether, you're going to get everything above the x-axis as your answer. So this is your graph. Now, if you want to sketch f of modulus of x, then you're going to have again a similar. So to sketch y equals f of modulus of x, what we need to do now is do the following. You're going to keep the right hand side of the graph all the way to the y-axis. Then you're going to delete the left hand side completely, and you're going to reflect the right hand side in the y-axis to obtain a perfectly symmetrical graph about the y-axis. So the final answer is going to be the reflected part and the original right hand side part. Now, why do we need to do this? Because you are going to apply the modulus to the x's to begin with. So if your x was less than 0 before the modulus was applied, it used to follow the left hand side of the graph. Now the negative x's, the modulus symbol turns them into their opposite brothers, the positives, and therefore whatever was on the left hand side, the negative x's, now will get the same values as the positive x's used to get. That's the reason for it. Okay, so modulus of f of x, reflect anything from underneath the x-axis up, and then f of modulus of x, delete the left hand side, keep the right hand side, and reflect it in the y-axis as well, so you get a perfectly symmetrical graph about the y-axis. So let's have a go at example 17. You've got a quadratic x squared minus 3x minus 10. We're going to sketch this quadratic. We are going to sketch the modulus of that quadratic, and we're going to sketch f of modulus of x. So let's sketch the quadratic function first. So let's factorize it. So this is going to be x minus 5, x plus 2, sorry. So that tells me that, let's say y, the roots are x is equal to minus 2 and plus 5. So here, it also intersects the y-axis at minus 10. So here's my graph. So this is y equals f of x. Y equals modulus of f of x. We just need to reflect the bottom bit of the graph in the x-axis. There you go. So normally it goes down here. It's going to go this way. So this is y equals to modulus of x squared minus 3x minus 10. And finally, for part C, we're going to draw the modulus, f of modulus of x. So this is the graph which you will obtain by keeping the right hand side of the original graph. So we used to go through -2 here, we don't want that anymore. We go through 5 over here, that's -10. So we imagine deleting the left hand side branch. Now we're going to reflect that part in the y-axis to obtain the following graph, symmetrical about the y-axis. There you go. This could be also written, instead of f of modulus of x, you could also have it written as modulus of x squared minus 3 of modulus of x minus 10. So let's have a look at example 18. So g of x is equal to sine x. We're going to sketch the graph and then do the same as in the example before. So find the modulus of that graph and then g of modulus of x. So sine graph looks like this. That's up to 360 from 1 to -1, but we need to go to -360. So this is g of x. Let's now find the modulus of that graph. So it's going to be the graph obtained by reflecting any negative part under the x-axis above the x-axis. So you will have a hill that was already positive, stay positive. The one on that was negative will pop up as well. And then you get another couple of hills on this side as well. There you go. And finally, let's draw sine. Now this one here would be written as modulus of sine x, if you, or modulus of g of x, if you name your graph as y equals g of x to begin with. So we want to keep the right hand side of our sine x, and we are going to imagine deleting all of that on the left hand side and reflecting the right hand side, because your negative x's will now get whatever the positive x's are getting. So minus, well, that would be the same, but let's say -90 will get whatever 90 would get, because it would change it to 90 first and then read off the answer of what sine 90 is. So this could be written as sine of modulus of x or g of modulus of x. There you go. So let's move on to example 19, and then you can have a go at exercise 2e. So in this graph, you've got a graph here going and having an asymptote at the x-axis, as x's are going tending to positive infinity. You've got 2 points, no, you've got A, B, C, D, E. You've got 5 points marked on the graph: -7, 0, -2.5, 15, 0, 11, 3, 0, and 6, -5. So we're going to sketch the graphs of modulus of h of x and state the coordinates of the moved points, so the images of those points after this transformation. So at the moment the graph is going through -7, so we are going to keep everything that's above as it is. So we're going to keep that hill like that, and then this one needs to be flipped above. So it used to go like this. Imagine reflecting it in the x-axis. Now this part went like this. Imagine reflecting it. It will go like that. So the point A, let's call it A dash because we've changed the function, is going to stay the same. That maximum point, also let's call it B dash minus 2.515, stays the same. So does this point, C dash, 0.11. D will stay the same, so let's call it D dash, the 3.0. Now E used to be at 6 minus 5. E dash is going to be at 6 and 5. There you go. And the second graph that we're going to do, we are going to draw the h of modulus of x. So we want to completely ignore the left hand side, and we are going to just copy the right hand side as it appears on the graph, something like this. Now the point E will stay, so let's call it double dash. It's 6 minus 5. This point D double dash stays as it did before. That's going to be 3.0. This one also stays as it was. And then you haven't got the images of B of A. The left hand side is totally gone, but the right hand side will be reflected in the y-axis. So you will have a point here, not sure what to call it, let's call it triple dash. So that's going to be minus 6 minus 5, because from 6, this one 6 minus 5, it goes to minus 6 for x. And point D, let's call it triple D, D triple dash, and it will be minus 3, 0. There you go. Okay, so yeah, and now going to exercise 2E.